Okay, so we're going to cover lesson 7.5, parts of similar triangles. Last week we learned what it meant to be similar triangles. And in similar triangles, what's true? What makes them similar? Corresponding angles are congruent and corresponding sides are proportional. Very good. Okay, so in today's lesson, we are going to learn that not only are the sides proportional, but there's some other things in the triangle that are proportional as well. Last week we also learned that the sides are not only proportional to each other, what else are they proportional to? You remember? The perimeter, right? So the sides are proportional to each other, yes. And they are proportional to the scale factor. Remember, the scale factor is a ratio of the corresponding sides. And they're proportional to the perimeter. And then today we're going to talk about these special segments. Now, these special segments we talked about in a previous chapter, okay, back before Christmas. And what are these little red segments right here in regard to the triangle? It's the altitude or the height, right? Okay, so if two triangles are similar, then the measure of the corresponding altitudes are proportional to the measure of the corresponding sides. So if these two triangles are similar, then these altitudes are proportional to any of the corresponding sides. So you can set up a proportion, QA is to UW, as QP is to TU, that's one pair of corresponding sides. QR is to UV, or PR is to TV. So your first ratio is the altitude. It is proportional to any of these corresponding sides. Ratio of any of these corresponding sides. All right. So the altitudes are proportional to a pair of corresponding sides. What are these blue lines here in regard to the triangle? They're what? Not the median. What does it do in comparison to this angle? They're bisecting it. So these are what? Angle bisectors. So this theorem says that the angle bisectors are proportional to a pair of corresponding sides. Okay, so I can set up a proportion. QB is to UX, and I can make it proportional to any of the pairs of corresponding sides. So I could do QP is to TU, or QR is to UV, or PR is to TV. So your angle bisectors are proportional to a pair of corresponding sides. So your altitudes are, your angle bisectors are. Now let's look at this last one. What are these guys? These green lines. These are medians, right? Because the median goes from a vertex to the midpoint of the opposite side. Okay? And your medians are proportional to a pair of corresponding sides. So I can set up a proportion. QM is to UY as PQ is to TU, or QR is to UV, or PR is to TV. So, in similar triangles, the sides are proportional to each other, okay? They're proportional to the scale factor, they're proportional to the perimeter, to the angle bisectors, the altitudes, and the medians, okay? They all have that relationship. They're proportional to each other, okay? All right, so let's do a couple of examples. In the figure, triangle ABC is similar to triangle FDG. Find the value of x. Okay, what are these two things right here? This x and this, or AP and FQ. They're angle bisectors, right? And we said that they were proportional to a pair of corresponding sides. Do these two sides correspond, the 15 and the 12? Okay, we can look at our similarity statement. 15 is AB and 12 is FD. So yes, they do correspond, right? So we know that those angle bisectors are proportional to those corresponding sides. So we can set up a proportion. So x is to 8 as 15 is to 12. Okay, so altitude to altitude, side to side. Cross multiply, 12x equals, is that 108? divide both sides by 12, and x is 10. All right, so x is 10. All right, let's look at the next one. In the figure, triangle ABC is similar to triangle DEF. It wants us to find EH, so this is what I'm looking for, and it says that BC is 30, BG is 15, and EF is 18. All right, so what are these? What is BG and EH? What are they? They're medians, right? And what do we learn about them? They're proportional to a pair of corresponding sides, right? So what can we do here? What'd you say? Okay, so how should we set it up? Okay, we can do that. X is to 15 as 18 is to 30. Good. Cross multiply. 30x equals, what is it? 90. That's 90.
Oh no, I did 5.
270. Okay, divide both sides by 30, and x is 9. Now, could I have set my proportion of 15 is to 30 as x is to 18? Could I have done that? You can almost just see that, can't you? Because that has a 1 to 2 ratio, doesn't it? Okay, so you could have set yours up like that. But be careful, because if you set yours up like that, it doesn't necessarily give you the scale factor. Okay, what would the scale factor be? Big triangle to little triangle. 5 to 3? Okay, good. So my scale factor, big to little, would be like what? 15 is to 9, which would be 5 to 3. You could also use 30 is to 18. Okay? Alright. Some of us are still having a little bit hard time getting that scale factor. Alright, here's another one. In the figure, triangle EFG is similar to triangle JKL. ED is an altitude of triangle EFG. JI is an altitude of triangle JKL. Find x if EF is 36, ED is 18, JK is 56. Okay. So these are altitudes. They're proportional to a pair of corresponding sides. So what can we do? Set up a proportion. What's it going to look like? Okay, x is to 18 as 56 is to 36. All right, cross multiply. And 1008. Divide both sides by 36. And x is 28. Now, this has a 1 to 2 ratio with the altitude and the side length too, doesn't it? So could I have done that? I could have, right? 18 is to 36, this would have been 28 is to 56. But again, that wouldn't have given me my scale factor if it asked me for the scale factor. So the scale factor has to be a ratio of a pair of corresponding sides. All right, now, this next theorem, put a big star by it, okay? People tend to forget about this one. The concept is not hard at all, okay? But people just forget about it. They kind of make up their own rules here. They come up with their own little theorems. It's not necessarily been proved. It's the angle bisector theorem. And it says that an angle bisector in a triangle separates the opposite side into segments that have the same ratio as the other two sides. So see here, CD is an angle bisector. And when it is drawn, it breaks its opposite side into a ratio that's the same as the other two sides. Okay? So I could set up a proportion, and I can do AD is to BD as AC is to BC. So you do opposite to opposite, side to side. Okay? So left to right, if you're going to look at it like that, okay? Or I could do opposite to side, okay? So I could do AD is to AC as BD is to BC. Either one of those proportions would work. Okay, the first one is left to right, okay? The second one is left to left, or left to side left, and right to side right, okay? Either way. Okay, so in this next problem, we see here that RT is an angle bisector by the marks there, okay? And I want to find the value of X. So what am I going to have to do? What do I represent ST with? 18 minus X. Okay, so remember, this angle bisector breaks this into a ratio that's the same as the other two sides. So what would that look like? Any ideas? Okay, so X over 18 minus X, okay, equals 6 over 14. Good. All right, so we cross multiply, and we get 14X equals 18 times 6 is 108 minus 6X. And so we add 6X to both sides, so we get 20X equals 108. Divide both sides by 20, and I get 5.4. So X is 5.4. You know, they can also ask you for ST, right? So they asked you for ST, you'd have to subtract that from 18 to get that length. So, not a hard concept, okay? You know, you have a triangle, and you draw the angle bisector, and what it's telling you is that it breaks the opposite side into a ratio that's the same as the other two sides. So then this, like here, could be 4, and this could be 6. So when you drop this, if you compare this as 2 to 3 as 4 is to 6, those are both 2/3, right? Or if you compare the opposite side to the adjacent side, that's 2 to 4 and 3 to 6. That's a ratio of 1 to 2. They're still the same, correct? Either way you look at it, all right? So you can do opposite side to opposite side, adjacent side to adjacent side, okay? Or you can do opposite to adjacent, okay? All right, any questions on that? We learned that in similar triangles, what all kinds of things are proportional? The what? The altitudes, the angle bisectors, the medians, the sides, right? It's also proportional to the scale factor, and what's the last thing? Parameters, okay? So all of those are proportional to each other, okay? All right.